right, good morning. This is Matt Rogers again. I'm with Heat Transfer Sales, soon to be known as Hoffman Hydronics. And we're here in the Heat Transfer Sales Hoffman and Hoffman building here in Greensboro, North Carolina, where we have our warehousing, pump rebuilding, our fabricating facility for all the pump and flow. And one thing that we do a lot of is we rebuild pumps. You know, we're the trusted person in the Southeast for if you've got an issue with any of your pumps, you send them to us and they get out like a brand new product. This morning, as far as the what, the hows, and the who's, the what, we're working on some old Taco FE pumps, FE series pumps, which was the series of pump that was the production of pump that was right before the current FI series pumps that we have out today. These started out with lubricated bearings, which you'll see on a lot of these bearing frames. You'll actually see that they still have Zerk fittings on them, okay, which means that these are a lubricated bearing on them. Whereas the newer or the later models of the FE series pumps, you're not going to see any Zerk fittings on them, okay, no bosses drilled, no fittings, and this is because these bearings actually were sealed bearings. And when we talk about the difference in a sealed bearing and a shielded bearing, it's the type of containment that holds in or keeps out moisture and contaminants, or holding in the lubricant, which in this case is a polyurea type of grease. And we're going to talk about grease and lubrication a little bit further on down the line. But as far as the what's, Mike Becker here, who is our pump build. Mike, if you'll let him see your pretty face. This is the pump builder over here at Heat Transfer Sales, and he's responsible for the disassembly, inspection, the maintenance and repair on all of these pumps that come through the shop. Also, if you order a new pump from Heat Transfer Sales, you're going to end up having Mike set that pump up for you, as far as making sure that the impeller is trimmed and balanced, the motor is set up, and that alignment can be verified. Although alignments have to be redone out in the field, as the little yellow stickers on top of all of the coupler guards will tell you, this pump has to be realigned before put into installation. Over here also we have, if Matt could step into the picture, another Matt. This is Matt Olenick, and he's our service manager. He's pretty much in charge of everything that goes on out here with the pump building, with the parts department, with everything as far as getting your pumps back into their perfect running condition. And this is one of your who's. So when I talk about who's, this is one of the guys that if you ever meet him, you talk to him over the phone, you need that information so that you can always contact Matt to get the right information that you need to help you with your problems. Right now we've got Mike. He's been over here disassembling this pump. And these pumps, the difference between like the FE series and the FI series pumps of these Taco pumps is the later FI series pumps don't have circlips on them that actually hold the bearings onto the shafts. It's a shrink fit only. Whereas the FE series pumps are actually going to have these retaining rings on them that are going to need to be removed, these circlips, before you can actually remove the bearings. Often people will not realize that these have these clips on them, and in the process of trying to remove that bearing by pulling or pushing it off, they end up destroying those circlips, and also they'll end up boogering up the grooves on the shaft and end up creating problems later down the line. So know what you're working on. Okay, so Mike has removed the circlip now, and one thing that we want to do to all our components, disassembling and before we assemble things, is to inspect all of our components. One thing you want to make sure on these circlips is that they're nice and flat. If they're cupped at all, it means somebody has tried to press this circlip off, not realizing it was there, and they've bent it and deformed it, and it's not going to do a good job of holding this bearing in place afterwards. So we want to make sure that it's in good operating condition. If not, You can try straightening these, but the best results you'll have will be with a replacement piece. Okay, secondly, when we look at this, Mike's getting ready to remove the bearings off of this shaft. And a couple of things that you notice, especially on these Taco shaft assemblies, is just how beefy the center section of this shaft is. And what makes it even better is it's a carbon steel shaft. It's not stainless steel. This is why Taco ends up using a dry shaft seal design, so that they can actually use carbon steel instead of stainless steel, which doesn't have the strength that the carbon steel is going to have. So Mike is going to remove the bearings, and when it comes to removing the bearings, you can remove these by pressing them off, by pulling them off with pullers, which we'll show you a couple of different ways, with a hydraulic press, with an arbor press. The main thing that you want to do is make sure that you don't use heat to try to remove these bearings, because anytime you put heat on these bearings, you're taking a chance of warping this shaft. Any heat that you put on this shaft that's not uniform all the way around is going to end up warping that shaft one way or another. And trust me, I know from experience that that means a replacement shaft, because you're not straightening these shafts out. So Mike's going to go ahead and replace those, remove those bearings for us. And while he's removing those bearings, let's talk about the bearings in general. Okay, when we're dealing with pump bearings, we're talking about a bearing that needs to be operating normally in that 105 to 150 degree temperature range. So whenever we're dealing with a hot water pump, we always have to be cautious, because once we start getting around 160 degrees on a bearing, you're getting to the point where the bearing is going to start having some issues. One thing that we do here in the shop is we've gotten to the point, all of the new Taco pumps use sealed ZZ series bearings. And so that's what we replace all our bearings in our pumps with. And this just keeps people from making the mistakes of using the wrong lubricants or over lubricating their bearings, which is a common failure point whenever you're dealing with bearings. And so what we're going to do is replace with sealed bearings. And because we're using sealed bearings, as we talked about, some of these pump casings are going to have Zerk fittings on them. Okay, you don't want to install sealed bearings and leave these Zerk fittings still in the casing, because someone is going to come in not realizing these are sealed bearings and start putting lubrication in. As they fill this bearing housing on the outside with grease, it insulates the heat inside those bearings, and it's going to cause bearing failure. So my suggestion is always to unscrew or knock out your Zerk fittings, and then fill that hole with something that's not easily removable. I like using lead solder. Put a little lead solder in the hole, and then on the bearing frame, write sealed bearings installed with a date on it. And what that does is it tells the person, because normally with a sealed bearing we can expect anywhere from 60 to 80,000 hours of use. That's like 10 years of 24/7 operation. So if we know that, and we're going to do the greatest type of maintenance, which is not preventative but predictive maintenance, we can have an idea of when we expect those parts to fail. Knowing that we can expect 60,000 hours out of it, at 30 to 40,000 hours, we can choose to replace these bearings. That way we tell the equipment when it's down. It doesn't tell us when we have to change our schedule to come and repair it. All right, so Mr. Becker has brought us our shaft assembly back over here, minus our bearings, and he's already cleaned this up. Okay, a couple of things when you're cleaning these. We don't want to change the OD of these. We don't want to physically change the dimensions that were put into this at the factory. The easiest way to do that is chuck this in the lathe and take a piece of sandpaper to it. You're going to ruin the dimensions of this shaft. The other thing is, try to stay away from taking your piece of sandpaper or emery paper and shoe shining these shafts to clean any areas, because when you do that, you're changing the dimensions of this shaft. The bearings are not going to fit on it correctly. Your shaft sleeves are not going to fit on it correctly. Your impeller will end up developing a wobble because of a loose fit, and all of those things mean poor serviceability and a reduced life. So we want to try to keep this thing as pristine as possible. So when we inspect this, we want to look for any nicks or cuts or scratches. And remember that anytime you make a ding or a nick in a piece of metal, we need to remove any of those high spots. And to remove those high spots, the best way to do it is just mark that area with a magic marker, and then take a fine-tooth machine file, not a real rough half-bastard file, but a nice fine machine file, and file only those high spots down until you get through the indelible ink and you start seeing shiny metal again. And then stop at that point and dry fit your pieces to make sure you've gotten rid of all your high spots. Okay, so Mike is now ready to install the bearings on this, and there are two things that we need to take into consideration when installing bearings. One, we don't want to do anything that is a destructive process. And by destructive, I mean anything that is going to force those balls into the race that could cause a ding or a nick inside of it that's going to cause a rough running bearing. So we want as gentle an approach to putting the bearings back on this as possible. There's going to be instances where you end up having to press a bearing on simply because the bearing heater that you have won't fit the diameter of the bearing. But typically what we try to do is heat the bearings up, heat the inner race of the bearing up to expand it. And at the same time, it's a good idea to constrict or contract this shaft by cooling it down. And a couple of ways you can do that. Here in the shop, you can take it to the freezer inside of the break room. We have an ice machine over across the way. Take that shaft, and while you're preparing all of your other components, put it in there for 10 or 15 minutes. It's amazing how much easier those bearings are going to slide on this cooled shaft, because it shrinks, the bearing expands, stuff goes together, and it rattles like a canasta. So when we pull our bearings out, and like I said, we're using a ZZ series bearing, which is a totally sealed, permanently lubricated bearing for a life of what we said was 60 to 80,000 hours. And when we pull it out, we always want to inspect all our components. Okay? And pushing and pulling, twisting and turning, making sure that we spend an adequate amount of time feeling for any ticks or tocks inside of this bearing. If you feel anything that has a tick to it, do not use that bearing. It's not going to get any better. Okay? Always use a very smooth bearing whenever you're putting this back together. And now Mike is going to go through the process of heating this bearing up and installing it back under the shaft. Okay, Mike's going to do the bearing for the other side of this, and then we're going to install it. One thing that you want to be aware of is this bearing is going to need to be cooled down to room temperature before you try to install it in this housing, because now the bearing is expanded and the housing is not. And to put it in, you end up having to use force that could end up damaging your bearings. So we're going to let it cool down before we insert it back into the housing.
You heard it pop. Yep, heard it pop right in there. You know you're good to go. And then we'll let it cool off before we drop it in our housing.
Okay, let's talk about using a different type of bearing. I said that when we repair them in the shop, we're trying to use the ZZ rated sealed bearings for maintenance and longevity. There are a lot of people out there that like to grease their own bearings. Okay, they like to have their bearings on a grease schedule. And for that, I'm saying don't be ignorant about what types of grease you need to be using, about their compatibility. Don't be ignorant about where your pump is, what kind of environment is it in. Is it in a situation where it's in an extremely dirty, hot environment? Is it on a chill water system where your bearing frame is going to be condensing and water getting into your bearings? Making sure that you're using the correct type of lubrication is extremely important. Okay, but if we're going to use a bearing that needs to be lubricated, typically What we're doing is we're using one of these CS series bearings, which just means shielded bearings. These have a dirt shield on them. It's just a little plastic cover. And these shields actually allow air and oil to penetrate them, and water, anything else that wants to go through it. But it keeps contaminants out of it as far as like dust and dirt. So what we want to do, if we're installing these onto a bearing frame that we're going to have grease fittings, and like in this grease fitting where you have your Zerk fittings, you'll notice that they're going to actually be lubricating to this side of the bearings. So I'm going to leave the shield intact on that side of the bearing, but on the inside of the bearing I'm going to remove these shields, because remember the two things we said that end up deteriorating our bearings is heat and dirt. When we're talking about heat, anything that is keeping those bearings from being able to dissipate the heat is going to create a situation where the bearings will eventually get overheated. That's why over lubrication is always a bad idea. A lot of people think, oh, I've got a bearing that's ticking, a bearing that's squealing. That's telling me I need to lubricate it. That's misunderstanding that bearing. That bearing is telling you it needs to be replaced. And a lot of people say, no, it just needed lubrication because when I pumped that bearing housing full of grease, the sound went away. All you did was throw a blanket over the noise. The noise and the problem was still there, and now it's going to be exasperated because the heat has nowhere to go. So understand what your bearing's telling you, and when you install these bearings that are going to be lubricated, make sure that you install them so that the shields are off and open to the inside of the bearing frame, which is protected from any dirt. There's no dirt inside the bearing frame. But because oil can penetrate this outside shield, when we do put lubrication on the outside, the way that the grease works is the grease is just a binder holding oil in suspension. And as that oil in suspension gets to about 100 degrees, it starts releasing the oil out of the binder, and then it can be sucked into the bearing, because as these bearings are rotating, they're creating centrifugal force that's pulling air through these bearings. And it's going to pull the oil into the bearings and lubricate them. A slightly lubricated bearing will outlive an over lubricated bearing every single time. Okay, so what type of grease do we use? From the factory, if you look inside of this bearing, you can see it's this light aqua blue grease. That identifies it as a polyurea based grease. Okay, the couple of different manufacturers that produce this, the one that we rely on is the Mobile Polyrex EM, which means electric motor grease. It's a very stable grease, works under our temperature ranges that we're going to be running these pumps at, and it has a nice longevity to it, to where if they put it inside of a bearing for permanent lubrication and expect to get 60 to 80,000 hours of it, you can expect that it's pretty good lubricant. Attached to this video, we're going to have a sheet that's going to pop up, and it's going to be pretty much lubrication, types of lubes to use, types of grease under extreme environments, under normal circumstances, different temperature ranges, and this and that, and also what the motor manufacturers recommend for their lubrication. Baldor and US motors specify Mobile Polyrex EM grease specifically for their bearings on their motors, and we'll use the same thing in our pumps. It's probably a good idea to look up your lubrications. Don't be ignorant about them, because the fact is that a lot of lubrications end up being counterproductive with one another. Lithium-based grease and a polyurea-based grease end up being like a catalyst for one another, and they'll create a hard lump that'll end up, instead of creating lubrication, will create a binder that ends up just doing nothing but insulating the heat inside that bearing. So be specific about what types of lubrication you use.
We're going to go ahead and put this back in the housing. You can see we've got our clip on it. We put it in the freezer to let it cool off a little bit so we can go ahead and work with everything. We're nice and clean inside, got all the old grease that was burnt up out of it. So we're gonna slide this in. It's gonna come out the back side. As she's coming in, then we're gonna tap it, take our hammer and we're gonna tap it in. And you should see it start sliding in there, no problem. The hotter it is, the harder it is to want to slide in there. And you can see it going down in, and you'll hear it when it bottoms out. And then you'll see a smooth surface across, and then we're gonna put our housing up and over. Put our bolts in. Then we're going to tighten those down and move to our next step, which will be putting the casing on and installing the seal, which will be on the next video. Be sure and don't miss that. And that's how we do it here.